So question 3, we have to prove that. So my function is equal to that. Then we need the second order and the first order derivative. So we apply rules of differentiation, product rule. So I can call this my u and this v. Let u be that v cos 3x. Differentiate u dx v dx negative 3 sine 3x. What do we do next? Then we substitute y dx is equal to v u dx plus u v dx. So what is our v? Our v is cos 3x, then du dx e to the x, then plus u e to the x dv dx negative 3 sine 3x. Then this is equal to minus 3 dy dx. So that is our first order derivative. We can do what? We can substitute y. So our dy dx is equal to y minus 3 exponential x sine 3x. Maybe I can call that equation 1. I've substituted ex cos 3x. I've substituted that value. Now we are going to obtain the second order derivative. We are going to differentiate this. So this is equal to d squared. So my y is actually ex cos 3x. So we shall differentiate that to get dy dx. It's a function in terms of x. So if we differentiate this y, we get dy dx, then minus 3. We are going to differentiate this function here with respect to x. Now we substitute. We evaluate this derivative. So this is equal to dy dx, then minus 3. Still product rule. We can call this u v. So substitute. The formula is here. V, which is sine 3x, multiplied with du dx, which is differentiate u, you get e to the x, then plus u e to the x times dv dx, differentiate this v, you get 3 cos 3x equals 3x. Then this simplifies to this. It's equal to dy dx minus 3 e to the x sine 3x, then plus 3 e to the x cos 3x. We have that. What can we do? We can substitute y. This function here is y. So this is the second order derivative. Dy dx minus 3 e to the x sine 3x plus this is 3, and this function here, ex cos 3x, that is y. That is y. Now we can expand this to obtain y dx minus 3 cos 3x, 3 times this, then 3 times this, minus 9y. We have that. So when you look at what we are supposed to show, this is sine, sorry, this is sine, this is sine. So we want to show this, so we don't need sine, How can we get rid of sine? How can we get rid of 3 exponential sine 3x? We can substitute it from equation 1. From 1, this is my equation 1, I can actually make this the subject. So from 1, what do we have from 1? From equation 1, we can make this the subject. Equation 1 is dy dx equals y minus 3 exponential x sine 3x. Make it the subject, we shall have this y minus dy dx. So substitute it back here. We shall have the second order derivative equal to dy dx minus this term here, minus that term, which is now y minus dy dx, then minus 9y. Simplify. This is dy dx, open brackets, minus y plus dy dx minus 9y. Then this and this simplifies to 2 dy dx, then negative y minus 9y, that is negative 10y. This is equal to a squared dx squared. So bring these terms this side, we shall obtain minus 2 dy dx plus 10y equals 0. So that is the required result. For question 3. Now we can proceed with question 4. Question 4. It is actually question 3. Just obtain the second order derivative. Play around with the first order derivative, substitute, then we get the result. So question 4, they wanted you to find the angle between the line r equals 205 plus lambda 312 from, find the angle between that line and the plane, negative x plus 2y plus 2z minus 66 equals 0. Negative x plus 2y plus 2z minus 66 equals 0. So you realize that we have a plane. We have a plane and a line. So we can obtain the angle between a plane and a line using this notation. D1, D2 sine theta. Using that formula. So D1 is the directional vector from the line. So D1 now is this vector from the line, directional vector from the line, which is this vector. And D2, that is the vector which is obtained from the equation of the plane, directional vector of the plane. These coefficients of x, y, and z. Yeah. So actually, you needed to identify what D1 represented and what D2 represented. So D1 is actually the directional vector from the line, which is 3, 12, 4. And D2 is a directional vector from this plane obtained by, I don't know which method you prefer, but you can first express this plane in this form. Because the equation is this is the equation. So this equation is the same as 2y plus 2z equals 66. You can take 66 the other side. Then I can actually represent this as the coefficient of x is -1, coefficient of y is 2, coefficient of z is 2. Dot this with x, y, and z. This is equal to 66. So this is the dot product of x, y, z with this vector here. Still, we'll go back to that plane. So D2 is this vector here. So D2 is equal to -1, 2, 2. That is D2. And D1 is that. Now we can substitute. We can substitute in the algorithm. We can substitute in that formula and try to evaluate a few things. Yeah. So D1 dot D2, this is equal to dot product of 3, 12, 4 with -1, 2, 2. And this is equal to, you multiply and add dot product. This times this, that is -3. This times this plus 24. 4 times 2 plus 8. -12 plus 24 plus 8. So what is that equal to? -3 plus 24 plus 8. 29. This is 29. 29. Then we can also obtain magnitude of D1 multiplied with magnitude of D2. Magnitude of D1 multiplied with magnitude of D2. So magnitude of vector D1, this is the square root. D1, this is D1 square root, 3 squared plus 12 squared plus 4 squared. Multiply this with square root -1 squared plus 2 squared plus 2 squared. This is equal to square root of 3 squared plus 12 squared plus 4 squared. This is 169. 169 multiplied with square root of 4 plus 4 plus 9. It's 4 plus. It's 2 squared plus 2 squared plus 1 plus -1 squared, which is actually square root of 9. Square root of 9. So this simplifies to square root 169 times square root 9 at 9. Now we can substitute back in the algorithm. So d1 dot d2, d1 dot d2, that is 29, equals this product here, 39 multiplied with sine theta. 39 multiplied with sine theta. So make sine theta the subject. Sine theta is 29 over 39. So theta is the arc sine of 29 over 39. So the arc sine of 29 divided by 39 48 48.04 degrees. So that is the angle between that line and the plane. Now we can proceed with question 5. Question 5, which required you to have some knowledge on how to solve inequalities. So question 5, solve the inequality. Solve the inequality 7 minus 2x over x plus 1 x minus 2 greater than 0. So to solve that inequality, we can first obtain what we call critical points. Critical points are the ones which determine where where that inequality will be defined. So you just, to obtain the critical points, you just equate the numerator to 0. You also equate the denominator to 0. So the numerator is 7 minus 2x equals 0. So of this, we obtain x equals 7 over 2, which is 3.5. We equate them to 0 and obtain the x values. So that is the numerator. Then the denominator, we have x plus 1, x minus 2 equals 0. So we have x plus 1 equals 0, x minus 2 equals 0. So x equals -1, x equals 2. So the critical points are if I start with the smallest value, that is x equals -1, followed by x equals 2, then x equals 3.5. Those are my critical points. So what next? Those are my critical points. So when you look at these critical points, we are going to analyze the cases below. We have -1, 2, 3.5. We are going to consider what happens for values which are less than -1. Also, what happens for values which are in between here, -1 and 2. The same applies to in between 2 and 2.5, and also for values above 3.5. So we shall have values x less than -1, then values which are between -1 and 2, -1 and 2. Also for values which are between 2 and 3.5, then values above 3.5. You draw your table. So this is our table. So our function is actually, let me try to make this small. We have x less than -1. X less than -1. So our function consists of the numerator, which is 7 minus 2x, the denominator, which is x plus 1, x minus 2, and then we have 7 minus 2x over x plus 1, x minus 2. So you start substituting in those values in those functions. So for values of x which are less than -1, substitute in the numerator and see what will happen. For example, we can take any value of x which is less than -1. We can take -2. 7 minus, so you substitute -2 here. 7 minus 2 times -2, we get +11. So the answer here is positive. Then still consider that same value, which is x equals -2. Substitute it here. Where there is x, we have -2 plus 1 and -2 minus 2. This is equal to -1. Here, if we add -2 plus 1, that is -1, then times -4, which is +4. When you multiply here, you get a positive answer. So this is a positive answer. Then you continue, -1 to 2 values ranging within that interval. We can take x equals 0. Substitute 0 here, we shall get a positive answer. Substitute 0 here, we shall get a negative answer. Continue. Values of x within this interval, we can take x equals 3. So we shall have 7 minus 2 times 3, which is 7 minus 6. We get positive answer. So also x equals 3, substitute here, x equals 3, we shall obtain a positive answer. Then for values above 3.5, substitute x equals 4. Here, 7 minus 2 times 4, that is 7 minus 8, we get a negative answer. So this answer is negative. The answer is negative. Then you also substitute here, x equals 4. We have 4 plus 1. Substitute here, 4 plus 1. Then 4 minus 2. When you multiply here, we get a positive answer. So this answer is positive. Then you go back. So the numerator here was positive, the denominator was positive. So positive over positive answer, we get positive result. Positive over negative result, we get negative. Then here, positive, here, negative. We have that. So we want all values of x. When you look at this question, we want all values of x such that this function is greater than 0. Values of x which ensure that this value is the function is positive. these are the values where we are having a positive sign. So here and here. So our solution is x less than -1, 2, 3.5, 3.5. So we have that result. We have that result. What next? Now we can proceed with question 6. Question 6. Question 6. We are required to evaluate this integral from 0 pi by 3, 1 plus cosine dy squared dy. Want to integrate this function. So we can first expand. That thing. We can first expand that function. We can first expand that function. So the integral from 0 pi over 3, 1 plus cos 3y squared dy. This is equal to integration from 0 pi over 3. Expand this. This is 1 plus 2 cos 3y then plus cos squared 3y y. What next? So we can integrate this. We can integrate 1. We can integrate cos 3y, but cos squared 3y. Integration of even powers. So if we want to integrate even powers, we shall use double angles. Integration of even powers. We shall use double angles. A moment. Let me first try to so integration of even powers requires the knowledge of double angles. So for that question, we need to know something on how to deal with double angles. So we are going to express cos squared 3y in terms of a double angle. Cos squared 3y in terms of a double angle formula. So what do we know? We know that cos 2 theta is the same as 2 cos squared theta minus 1. So now what if I'm having 2 cos squared 3y? If I'm having this, you just compare. So I have minus 1. Then to move to this side, just multiply this angle. The formula is called double angle. So you double this angle to obtain what is this side. So this is cos 6y. Make this the subject. So if we try to make it the subject, bring 1 this side, shall have cos 6y plus 1 equals 2 cos squared 3y. Divide both sides by 2. Cos squared 3y becomes a half cos 6y plus 1. Half cos 6y plus 1. Now we can substitute back. So our integral, which I'm calling I, is now equal to integral from 0 pi over 3 1 plus 2 cos 3y, then plus a half cos 6y plus 1 dy. So this is the same as integration from 0 pi over 3 1 plus 2 cos 3y, then plus a half cos 6y plus a half plus a half dy. Now we can integrate. We are free to integrate that. We can evaluate now that integral. So this is equal to so if we integrate 1 with respect to y, we get y. Integrate cos 3y, so there is a 2. When you integrate cos, you get what? If you integrate cos, you get sine. Integrate cos, you get sine. So integrate cos, you get sine, and we have 3y. So you get sine. So that is 1 over 3 sine 3y. Let me hope you agree that if I integrate cos 3y, I get a third sine 3y. Now that is not part of the working. That's why I'm trying to ignore that. But maybe if you don't know, the integral of cos 3y dy, you let m be the angle. You let m be the angle, which is 3y. Then the m dy is 3. Now we want to change the variable from y to m. So we shall also have to substitute dy. So make dy the subject. Dy is actually equal to, dy is the m over 3. Now substitute back the integral of cos 3y dy is equal to integral of cos 3y is m times the m over 3. Dy is the m over 3. And so we can put a third outside, a third integral cos m the m. When you integrate cos, we get sine. So this is a third sine m. What is our m? 3y. So this is a third sine 3y. A third sine 3y. So now we can proceed with this was just side work. If you don't know how to integrate cos 3y, that's how we evaluate that integral. So also here plus half times integrate cos 6y. You first differentiate the angle. Differentiate the angle, you get 6. Write the reciprocal of that result, which is 1 over 6. Differentiate the angle, you get 6. Write the reciprocal of the result, which is 1 over 6. Then sine 6y plus half y plus a half y. So this is equal to, we also have our limits of integration. Limits of integration 0 to pi over 3. Pi over 3. So this is, we can actually simplify. We have y plus a half y. Y plus a half y. That is 3 over 2 y, and plus 2 over 3 sine 3y, then plus 1 over root of sine 6y, 0 pi by 3, 0 pi by 3. Now we can substitute pi. This is 3 over 2, where there is y, we put pi over 3, then plus 2 over 3 sine 3 times pi over 3 plus 12 sine 6 times pi over 3. Then minus, if I put a 0 here, 3 over 2 times 0, that is 0. Sine of 0 is 0. Sine 0 is 0. So there is no need for substituting 0 because I will get 0 throughout. If I substitute for 0, so this is, I can simplify. This 3 goes with that, so this becomes pi by 2, then plus 2 over 3 sine pi, this goes with that, plus 1 over 12 sine 2 pi by 3, 1 by 3. Now observe that your calculator should be in radians if you are dealing with small angles. Pi is 3.14, so it is a small angle. So you evaluate that in your calculator using radians. 2 divided by 3 sine pi plus 1 divided by 12, sine 2 pi. So we have 1.5708 for decimal places. Actually, you realize that the answer is pi over 2. That answer is pi over 2. Why pi over 2? Because sine 180 is 0, sine 360 is 0, sine pi is 0, sine 2 pi is also 0. Now we can proceed with question 7. Question 7. They wanted you to express 2 sine theta plus 3 cos theta in form of sine theta plus alpha. Sine theta plus alpha. Now, for that case, that is the R formula. We want to express what? We want to express 2 sine theta plus 3 cos theta in the form of R sine theta plus alpha. So we have 2 sine theta plus 3 cos theta. This is equal to, now you expand with compound angles, the compound angle formula for addition of sine. So this becomes R sine theta cos alpha, then plus R sine alpha cos theta. So they want us to express this in that form. So we have to substitute what R represents, what alpha represents. So to get the value of R and alpha, you equate coefficients. So you realize that here we are having sine theta, also here we are having sine theta. The coefficient of sine theta this side is 2. So what am I trying to do? I am equating coefficients I'm equating corresponding coefficients. The coefficient of sine 2 theta this side is 2. Coefficient of sine theta this side. Coefficient of sine theta is 2. Coefficient of sine theta is r cos alpha. I can call that 1. Coefficient of cos theta this side is 3. Coefficient of cos theta this side is r sine alpha. This is equation 2. We are going to play around with those two equations. How are we going to deal with them? Let us add them. When we have squared them. Equation 1 squared plus equation 2 squared. Equation 1 squared. Equation 1 squared is r cos alpha squared. R cos alpha squared. Then plus equation 2 squared is r sine alpha squared. This is equal to equation 1 squared 2 squared. So we add this and this when we have squared them. Yes. So square this side, also square this side. Square this side, also square this side. Then add. We shall have this squared plus this squared equals 2 squared plus 3 squared. So this is r squared cos squared alpha plus r squared sine squared alpha equals 4 plus 9. 4 plus 9. You realize that r squared is common. Pull it out. We shall have this equals 13. What do we know? We know that from the first trigonometry identity, we know that cos squared plus sine squared is 1. So this is 1. We shall obtain r squared equals 13, implying that r is actually square root of 13. R is actually square root of 13. Now we can obtain alpha. How are we going to obtain alpha? It's just a matter of playing around with equation 1 and 2. Equation 1 and 2. So for the first case to obtain r, you square 1, then you add it to 2 when you have also squared 2. So if you want alpha, we are going to divide equation 2 divided by equation 1. Equation 2 divided by equation 1. So what is equation 2? Equation 2 is r sine alpha equals 3. That is equation 2. Divide it by equation 1. So divided by r cos alpha divided by 2. So r cancels out. Sine over cos, that is tan alpha equals 3 over 2. Implying that our alpha is actually the tan inverse of 3 over 2. The tan inverse of 3 over 2. What is the arctan? Arctan of 3 divided by 2. Arctan of 3 divided by 2 is 56.31. So this is 56.31 degrees. Now we can substitute back. I have r, I have alpha, I also have the value of r. So 2 sine theta plus 3 cos theta is equal to r, which is square root 13. R is the square root of 13. Then sine theta, then plus 56.31. So r in this case is square root 13. So they wanted us to express this equation in this form, where r is this and alpha is 56.31. So we are going to proceed with the last question of section A. The last question of section A. And what was that question? Expand expand natural logarithm 2 plus x, natural logarithm 2 plus x in Maclaurin's series form. Maclaurin series form. Expand this using Maclaurin series up to a term in x squared. Expand natural log in Maclaurin series up to a term in x squared. So that was question 8. Question 8. Express that in ascending powers of x. Express natural log 2 plus x in ascending powers of x. In ascending powers of x. In ascending powers of x. Now, what do you know about Maclaurin series expansion? Maclaurin series expansion is actually Taylor series expansion about x equals 0. Taylor series expansion about x equals 0. So the expansion is f of x equals Taylor about x equals 0. Yes. So we are obtaining Taylor series expansion about x equals 0. So this is f0 and plus f 0 x plus f0 x squared over 2 plus. Now you need not to cram that. Yeah, the formula is there in the logbook, there in the mathematical tables. Yeah, it is provided. Now our function f of x is natural logarithm 2 plus x. So we want f of 0, where there is x, we put 0. F of 0 is actually natural logarithm of 2. Also want f derivative 0. We have to first differentiate, obtain the first derivative. So the first derivative of this function, how we differentiate natural logarithm. You differentiate this function here in brackets, differentiate this, you get 1 then over the same function. So this implies that f prime of 0 is where we are having an x, you substitute 0. So we shall come up with a half. Yeah, a half. Then also need what? We need the second derivative. Second derivative 0. We need that. So the first derivative is this 1 over 2 plus x, which I can actually represent as 2 plus x power negative 1. 2 plus x power negative 1. Differentiate this. The second derivative is equal to, differentiate this to the power negative 2 plus x. You drop the power, differentiate what is inside. The power is negative 1. Differentiate what is inside, we get 1. Then you rewrite the function when you have reduced the power by 1. So this is negative 2 plus x power negative 2. The second derivative. Then we substitute what? We substitute 0. The derivative at 0. This is equal to negative 2 plus 0 power negative 2. This is equal to negative 2 power negative 2. So this is the same as negative a quarter. Yes, negative 2 power negative 2 is negative a quarter. What now? What next? We can substitute back. We can substitute back in our formula. So fx is equal to f of 0, which is natural log 2, then plus f derivative, first derivative at 0, which is half x, then plus the second derivative. The second derivative is negative 1/4, that is the second derivative, divided by 2x squared plus. So this is natural log 2 plus a half x minus 1/8 x squared plus. So we obtain that as our required expansion. So that marks the end of section A. That marks the end of section A. So we shall proceed with section B. 60 marks.